All right, so now that we know what it takes to figure out if a matrix that's more than 2 by 2 is invertible and what the inverse is, let's do some examples using this. So what we're going to do with each example is set up this augmented matrix, and then we're going to see if we get the inverse and A inverse, sorry, the identity in A inverse, or not I and junk. All right, examples. All right, first example, I'm going to do 2 by 2s just because it'll be quicker, but this works for all sizes, all square matrices. All right, so let's say A is 1, 3, 2, 4. All right, so what are we going to do? We're going to set up this augmented matrix, where on the left side I have matrix A. On the right side, I have the 2 by 2 identity. All right, so then we're just going to perform row operations to see if we can get the identity on the left side. I already have my leading 1, great, so I'm going to use this to turn this 3 into a 0. All right, so I'm going to be updating R2. I'm going to multiply -3 times R1 plus R2. All right, so when we do that, we're going to get a 0 right here, -2, -3, and 1. So don't forget to also update the right side when you're doing this. All right, now I need to get this 1 here, so I need to multiply row 2 by -1/2. Okay. All right, all that's left is to turn this 2 into a 0, so I need to multiply row 2 by -2 and add it. All right. -2 and 1. All right, what does the result look like? Looks like we have identity on the left side, so that means A inverse is on the right side. So we're in this first situation. A is invertible. And A inverse is -2, 3/2, 1, -1/2. And you can always check this using our earlier theorem. All right, so you can check this on your own to make sure that we got it right. All right, let's look at another example. All right, I'm going to do another 2 by 2 just to save time. All right, down my columns, I got 1, 2, 2, 4. And I want to see, is this one invertible? What is A inverse? So that means, what are we going to do? We're going to set up an augmented matrix with A on the left side, identity on the right side, and row reduce. All right, so I'm going to get the 0 here. So that means down here I'm also going to get a 0 and then negative 2, 1. All right, notice I have this 0 in my pivot position. Will I ever be able to get the identity over here? No. This is not the identity. We'll never get it, which means this is junk. It's not the inverse. So what does this mean? A is not invertible. And also, we can check this by finding the determinant, right? Oh, the determinant was 0, so that means, oh, A actually is not invertible. We can't do this. All right, so again, you can do this method on way bigger matrices than 2 by 2s. And that's the end of this section.